We're on the final lesson of Chapter 6, in which we're going to solve systems of inequalities. First, we're going to graph a system of 2 linear inequalities. Then we're going to graph a system of 3 linear inequalities. Then we're going to write and solve a system of linear inequalities. If you remember, inequalities work a little bit differently than equations. For example, if I graph this inequality, y is less than or equal to 2x minus 3, then here's that line that shows the equal to. Y would be anything less than that, meaning that y is anything below this line. Same thing over here. When y is less than or equal to this amount, that means here's the line that shows the equation. It is anything less than that. So if these two inequalities were part of the system, this would be the area where they are both true. So the answer is a much larger space than an equation. You could even get more inequalities in there as well. Here we have y is greater than or equal to 3. That means anything above this line. So therefore, this space over here matches all 3. It's below this red line, it's below this blue line, and it's above this black line. So you can graph these inequalities and find the area of solution. First, let's start with 2. We're going to graph this system of inequalities. Y is greater than negative x minus 2. So if we're going to plot this one out, we're going to go negative 2 at the intercept, then we're going to plot the negative slope, and then extend it backwards. Notice how I made this a dotted line, and that it should be because it's greater than and not greater than or equal to. So it's greater than this, right? So it's anything above that line. Now we have y is less than or equal to 3x plus 6. So we go to our y-intercept of 6, so 3, 4, 5, 6. Then we can plot our positive 3 slope, or I can go backwards here and do our positive 3 slope this way. And extend that line. Remember, this is a solid line because it is less than or equal to. So it'd be anything that's less than this line because this is less than or equal to, so anything below this line. So what's above this line, this blue line, but below this black line? Well, it'd be anything over here, above the blue line, below the black line, so I can color that whole space in. So we can see that everything in this area that is shaded green is below this black line, above the blue line, so therefore it is a solution. I could plug in positive 3x, positive 2y, for example, and that would be true for both of these statements, and you could try it out. But let's move on. Now we're going to graph the system of 3 inequalities. We have y, which is greater than or equal to negative 1, x, which is greater than negative 2, and then x plus 2y is less than or equal to 4. So if we're going to do y is greater than or equal to negative 1, here's negative 1, we draw our line, so it's going to be above that because it's greater than. We have x is less than negative 2, so we go to x at negative 2, draw our line. X is going to be greater than that, so it's anything to this direction. Now we have x plus 2y is less than or equal to 4. Let's do slope-intercept here. So 2y is less than or equal to negative x plus 4. Let's make sure we get that or equal to in there. Divide both sides by 2. So that would give us y is less than or equal to negative 1/2 x plus 2. Make sure that's less than or equal to again. So here's our slope-intercept equation. We'll start at our intercept at positive 2, and then our slope is negative 1/2 x. So over 2, down 1, over 2, down 1, over 2, down 1. So now we can plot these points as a line. It's less than or equal to, so we'll use a solid line again. Trace it backwards. So where are the answers to our system? Well, we have y at negative 1, everything above y at negative 1. We have x at negative 2, everything above that, so to the right of that. Then we have everything below this line right here. So if I'm looking at that, it's going to be this triangle in here that matches all 3 types. So if I draw that in, this would be the area which matches all 3 kinds of answers. So for example, if I chose 0, 0, this would be 0y, which is greater than or equal to negative 1. This would be 0x, which is greater than negative 2. And then 0x, or 0 plus 2 times 0, which is 0, is less than or equal to 4. So this is true for all three inequalities. Anything in here that would be green would be true. So that's how we can determine answers for these systems. Let's write and solve a system then. The National Collegiate Athletic Association, or NCAA, regulates the lengths of aluminum baseball bats used by college baseball teams. The NCAA states that the length in inches of the bat minus the weight in inches of the bat cannot exceed 3. Bats can be purchased at lengths from 26 to 34 inches. So it says write and graph a system of linear inequalities that describes the information given above. So it looks like we're measuring weight and length. So we can go weight over here and length over here. So we can find out a system of inequalities here. So then length would be y, weight would be x. So it says that length minus weight cannot exceed 3, meaning that y minus x must be less than or equal to, that's what cannot exceed means, less than or equal to, and then that's got to be 3. So that would be our first inequality here. We also see that it must be purchased from 26 to 34. So that's the lengths, which would be y, meaning that y must be at least, so that'd be greater than or equal to 26. Then y must be no greater than 34, so y is less than or equal to 34. So this becomes my system. The length minus the weight must be less than or equal to 3. The length must be at least 26, and it must be no greater than 34. So if we make this slope-intercept form, that would be y is less than or equal to x plus 3. So therefore our slope starts at 3, and then it's rise over run. So run of 1, rise of 1, run of 1, rise of 1. We can take this all the way through. Let's draw a line. So that must be the length to width ratio. And then y must be at least 26. So 5, 10, 15, 20, 25. Here's 26. So it must be at least that. And it could be no greater than 34. So 25, 30, 35. Here's 34. So that means if we're going to color this in, it has to be less than this line here. It has to be less than this line here, but above this line here. So that means this whole area would be acceptable by the NCAA rules. So for example, a bat that weighed 30 ounces and had a length of 30 inches would be legal, as would any of these points as well. But let's take a look at this bat. Sporting Goods store sells an aluminum bat that is 31 inches long and weighs 25 ounces. Use the graph to determine if this bat is legal. So we can go to 31 inches here, then we go to the weight of 25, and we notice that's just outside the range. This is not going to work. And we notice it's because the difference between length to width is greater than 3. If it was below 3, it would be below this line. But since it's above it, we know it breaks that rule. So this bat could not be used in the NCAA. Could not be used.